Yeah, welcome back. In our previous discussions on the operations on binary search tree, we worked on searching a node, and then we looked into inserting a node. And in today's discussion, we'll talk about deleting a node. And in our coming videos, we'll find working on these two topics as well. In case of deleting a node, there is a trick. The trick is that we have to face several different situations, out of which one is that I have to delete a node with no children. And we may come across a situation in which I'll be deleting a node with one children, and the last option is deleting a node with two children. That means I may come across a situation where I have something like this and I have to delete. I may come across a situation where I have something like this, then I have to delete this, and that means here, in this I have to delete this. Then I may come across a situation where I have to delete this particular portion, right? And above also we can have something to it, right? There is a possibility that I may have some portion of tree above this as well. So looking at these options, the complexity increases from this, right? So this is with the minimum complexity, minimum possible. This is with the maximum possible complexity. So let's see how this particular algorithm works. Now, looking at this particular algorithm, this looks to be very complicated one. So don't get confused. I'll try to explain you with the help of several examples, so that would give you an ease. The only thing which we need to take care of while deleting a particular node is that the deletion should be done taking the properties of the binary search tree with utmost importance. That means all the properties of binary search tree should not be violated. Now, so what this algorithm is doing is initially actually it is looking for this, that whether I may come across a situation where I have to go for deletion but the tree itself is empty. So very first step we'll declare it. Or else based on the comparison, which is once again done just because of the kind of values we have and the property, I have to move towards left and right? And then based on this, some amount of operations which we are going to take, that I'll explain in next few minutes. So to start with, what we have is we have deleting a node that has no children, right? Deleting a node that has no children. And by this condition, we can also say that we are going to delete a particular leaf node. That is also a possibility, right? That's a property of a leaf node. That means it does not have any child. So that means we are going to delete a node with no children. That means we are going to delete a leaf node. So this particular case is the simplest case. That means I have to replace the node with the null and we need to set it free. We need to remove the allocated space. Let's take one example. Let's take one random example. Let's say So what we are going to do is we are taking, let's say I have a node like this, then I'll have something which is lesser than this. On this I'll have something, let's say, which is greater than this, and on this side once again I have something which is lesser than this, and let's say I am taking once again a value which definitely will be greater than my root node, and then what we have is once again some value greater than this, on this side smaller than this. Let me add some more to it, so 70 and maybe 85 here. Now what I'm supposed to do is I have to delete, let's say, this particular thing, right? 85 leaf node, or even I can take this as well, any of these possibilities, right? So this comes into picture, this comes into picture, this comes into picture, this one and this node 100, and I have to delete any of these, let's say. So what I'm supposed to do is simply I'll be assigning, I'll be making this particular value free. I'll set this free. I'll delete this particular node, let's say I'll be deleting this particular node. In that case, what I'm supposed to do is, for this particular node, so right now I'm talking as far as implementation is concerned, so this will have the address of this. On this side I'll make it null, right? So it's not pointing, so it is, I'm setting it free, right? You can use all those memory allocation functions for this particular implementation. So as I said in the very beginning that it is a simplest case, I'm simply setting the things free. Now in the next part, let's improve the complexity of it. So I'm going to delete a node with one child, right? So let's take another example, and let us take same set of values, so you'll be feeling comfortable with the kind of examples which we are taking. This was 35, this was supposed to be 10. On this side we had these set of values, of course 100 and 80, and then let me add some more, 85 and then 75, right? And let's say I have to delete, okay, so here my example is not complete because there isn't any node in which I have one child. So let me add some more to it. Let me add 15 to this particular thing, and our aim will be to delete this particular node. Right? Sorry. Our aim will be to delete this particular node, not this, because this particular case we have already covered. Now I have to delete 10 from it. In this case, what I'm supposed to do is I'll replace the node which I'm supposed to delete. With its child node. Right. Once again, a simple concept. So what I'm trying to say is simply replace the node which is to be deleted with its child node. So in this particular case, I'll be replacing (10) by 15. Right. So how my new tree is going to look like, let's quickly see how my new tree is going to look like post deletion of a node, and that would be this one. So 60 remains intact, your 30 remains intact, this side your 90 remains intact. So on the right hand side, the entire content remains intact, no change on this particular end. Whereas on this side, what I have is I'll be replacing this 10 with 15, and this becomes my resultant tree. So what I observe is that there is some amount of change which we received from here. Once again, comparatively simpler approach, but yet you have to do some amount of replacement. Now, what kind of replacement? Let's see. In this particular algorithm, where we are, of course, we looked into this particular portion. We are done with it. Now we are moving towards this. Right. And we have taken care of movement part as well. So how we are going to deal with it is that as far as coding is concerned, you have the basic detail about this, you have the basic detail about this. Easiest implementation is copy the address of this particular node to this. That means on this particular node 30, instead of having the address of 10, now I'll have address of 50. That's how we'll be able to, and we can of course release this particular memory. So once again, a pretty simple concept. Now a bit tricky, just because of having some properties associated with a binary tree. Now we are going to go ahead with deleting a node with 2 children. Right, deleting a node with 2 children. So let's see this example. Our very old example where we were having values like 60 on this and 30. Why I'm taking the same example is to give you the entire feel of how this is taking place. 10, then we have 35 on this end, we have 90, and then we have 80, we have 100, we have 75, and we have 85. Now, in order to handle this case, what we do is we replace the node's value with its in order predecessor. I hope you are aware about the in order predecessor. That means the largest value in the left subtree, or the in order successor. That means the smallest value in the right subtree. Getting this part or not? So let's take this example where, so let's assume I have to delete this particular node from this tree, and we have two options, right? As I said, either I replace the node value with the in order predecessor, or the in order successor, which will be the smallest value in your right subtree. Right. So in this case, what we see is, in case of the right subtree, which appears to be this, the smallest value is this, right? So how my tree is going to look like: 75 on this end, 30 remains intact, 10 remains intact, 35 remains intact, this entire portion remains intact, 80 comes here, 100 comes here. I don't have anything on this side because we have replaced it. Let's say this, which is further deleted, right? Which is further deleted. So this is the only trick in this particular case, whereas in the previous case things remain simple. In this case the things remain simple. Once again, here in case of deletion, you have to make this particular value free, and the address of this particular thing is copied here. So that's how we make the choices. Simple copy paste is to be done. So with this we finish the deletion part, and we'll talk about two more operations, which is finding the height and finding the number of nodes, in our next video.